So I am recording. What is the video? Yeah, that's what we want. And what about yeah. Okay. All right, that's good. All right. Let's see. Test. Good. All right, so everything works. All right, so let's share screen. That's all right, so this is actually working, I think. All right, so let's go back. All right, probably not that direction. Let's go the other direction. All right. Oh, by the way, what is this? Precalculus, common assessment number 2, power and polynomial functions. All right. Hopefully you'll watch this video before you attempt to do the makeup for this exam. All right. So let's get right started. The function g of x is graph as shown. Here's g of x. Okay. Based upon this graph, g of x has which one of these? Okay. Looking at g of x, we're going to go straight to it. Let's identify the roots. There are 4 real roots. Let me annotate this. And let's see. Let's annotate this. We're going to so let's do that. So I got a real root here, and here. Okay, that's a little thicker than I want that to be. Let's go smaller. Oh, that's better. Now I got it raised. All right, so let's try this again. All right, we want to get 4 real roots. 4 real roots. There's 1, 2, there's 3, there are 4 because they're all on the real number line. They're all on the real number line. So you got 4 real roots. All right, and you also have a relative minimum. This right here, which I will do in, this is a relative minimum right there. So you got a relative minimum right there, and you have 4 real roots. How do you know it's a real root? Because it's on the x-axis. It's on this line right here. Those are what the real roots are. Okay. All right. You also have a you have an absolute maximum. Here you actually kind of have 2 absolute maximums, but they're not asking about that. So none of these others will relate to that. Okay, but it has 4 real roots. Doesn't have an absolute minimum. It has a local minimum, but this is not an absolute minimum. Why? Because this graph never stops. It never stops. Okay, so matter of fact, yeah, it never stops. So that's probably a long explanation for that. Let's go on to the next problem. Okay, so and let's go to the next. How do you do that? Clear. All right. Polynomial of degree 5 is graphed. Okay, and I'll try to go a little faster this time. Which statement is true? It has 5 total roots, 3 are real, and 2 are imaginary. All right. Here's the big thing about this particular graph here. It says this has degree 5. Degree 5. There should be 5 x-intercepts. Instead, I only see 1, 2, 3. So I am missing 2 intercepts. And that when that happens, that means you have 2 imaginary roots. So you have 5, this is true. There's 5 total roots, 3 of them are real, and 2 are imaginary. Okay? All right, and the only reason you can say that is because it's degree 5. Okay? So, and so the rest of this does not apply. Okay, let's go to the next. Let's see. Whoops. Let's see. I'm going to clear. Let's go to next. Let's go to the next. We'll get better at this. All right. Use the graph of f of x to determine over which intervals the function is increasing. All right. So let's look at where the function is going up. Okay. And so here's where the function is increasing. It starts right here. Starts right here and it goes up to about right there. Okay. All right. So that means, and you're going to look at the x values for the interval. So it starts going up when x is 0 and stops increasing when x is 1.063. So that's the only place where this graph is increasing. Everywhere else is decreasing. So which one is that? It is C. It is C. On that interval from 0 to 1, even though that's yucky. That's a misprint, but it's supposed to be 1.063. That's what it is. So the real answer to this problem is this. Okay, that right there is a typo. Okay, that I did not see. Okay, all right, let's go to the next problem. So the correct answer is C. All right, let's clear. All right. All right, let's select the description that best matches the graph of f of x. Okay, we want is f of x symmetric about the origin. It is odd and have an absolute minimum. This function, because of its end behavior, both of these are going up. Yeah, both of them going up. This is an even function. All right, so it is not an odd function. It's an even function. So we can strike out A. All right, and we can also strike out B because this is an even function. So let's see if it's symmetric about the y-axis is even and it has two real roots. Well, I see one real root and I see another real root. Okay. Let's look at the other one. Symmetric about the origin? Not if it's an even function, it's not. So all functions are symmetric about the origin. Even functions are symmetric about the y-axis. So that's why B is the answer to this problem. Let's keep going. Let's keep going. So all right, now this one. All right. If h of x is x cubed plus 2x and g of x is equals a negative 3x plus 1, what is g of h of x? All right, let's do this the way we did it in paragraph. Okay, so I am going to, let's do this. All right, let's, whenever you're doing a composition, you want to start with the outside function first. So g of x, well, we'll just, let's do it like this. All right, where is my g of x? Let's do g of x. G of x. I want to get rid of the x, and I'm just going to write g without x in it. 3 parentheses plus 1. That's g whatever. Okay. So if I was find g of h of x, then I need to put h of x inside. So let me go ahead and expand this a little bit. I'm going to write g of x again. -3 with parentheses. All right. Then I'm going to take h of x, all right, and I'm going to put it inside. So I got 3x squared plus 2x. All right, and that's it. So now all we're going to do is simplify this. We will get -3 times, that's the distributive property. And let's not forget -3 times 2x. -3 times 2 is a -6x. And we don't have the -3 on the 1, we can bring that down. So that's what I found out here. Which one does this look like? Okay. Right. Let's keep moving. All right, we can do this one. Since you guys are gonna be at home most of the time to do this makeup, I'm gonna do this in Desmos. Okay, so let me see if I can get Desmos up here. The problem with that is I'm gonna have to remember what the problem was. So let's do it like this. Let's see. I got g of x. I'm just going to write this down. I'm off counter. 3x minus 2. That's f of x. And I have g of x is negative x. And I want to find g of f of -4. Okay, actually, this one was pretty easy to do by hand, but I do it both ways. So let's do it by hand. By hand, we're going to do, we need to find g of x. So I'm going to draw g first. It's negative parentheses. That's g. All right, get rid of x. Then I'm going to put f of x inside. So, f of x is 3x minus 2. So now I'm going to simplify function. That's going to give me a -3x plus 2 because I am distributing, right? And so now all I got to do is substitute 4 in for x. So that's going to look like this. -3. -4, so that goes plus 2. Well, this is +12 plus 2, and that's equal to 14. And down some 14. So that's how you can do it. That's how you can do it by hand. But we can also do this on the with Desmos. So let's see if I can pull Desmos out here. Let's see, go to my screen here. Desmos is right there. Well, I need my mouse back. And place here. All right, that's good. All right, so let's move this, and let's put in our functions again. All right, so I should be able to put in f of x is 3x plus 2. So let's get f. How you know me? I like this. Brilliant. Okay. So f. Where's my f of x equals to 3x minus 2. All right. We're not really panicking. We're not using the graph really. And then g of x is -x. G of x equal to, I guess I use the negatives. negative x. All right. Well, we want to find it, and again, we're not even worried about this over here. What is g of f of negative 4? G, yeah, g of f of negative 4. And you can already see the answer, 14. Yeah, so there's both ways there. Okay. All right, let's get back to that. All right, so that's all right, now let's get this. We still got some ways to go. All right, if you need to take a break, take a break. You can always stop the start video. That's why I'm just going to do this all one long video. Okay, so which coordinate grid represents the graph of a function that is a fourth degree polynomial with no real roots? Oh boy, do I want to make a big deal about that? No real roots. No real roots. No real roots. That means it has no x-intercepts. So it doesn't have any rocks. So it should never cross the x-axis. So which one of these cross the x-axis? Well, it's only one. One does. So, not that one. All right. The rest of them, look at what the x-axis is. Just in case you have a hard time seeing what the x-axis is, there it is here, there. So this one on, but this one, because it has x-intercepts, that one's wrong. Okay. All right. So all these work. Now we need to talk about a range. We got to talk about a range of y is greater than 4. So we're looking, I'm going to draw where y is greater than 4. I'm just going to go to y-axis and draw where y is greater than 4. And I can even do it on this. It's off there. So that one's gone. So which one of these matches up with that green line? B does. There's your correct answer right there. All right. That's all your correct answer. Let me do an undo so you can see that again. Here's everywhere where y is greater than 4. I don't like it. And you see it, that's exactly where this function starts on the y-axis. So that's why. That's the answer for that. Clear that. All right. All right. Oops. All right. Forgotten how I kind of missed on this. What graph represents the function f of x equals to negative x to the 7th minus 2x to the 4th. Now you could do this 2 or 3 ways. You could just graph it. You know, that's one thing, and we'll do that second. But the way that we really wanted to do this is kind of have an idea that this is an odd function that's been reflected. All right, so it's reflected about the x-axis. So this is a reflected odd function. Now, odd functions normally look like this. Odd functions will normally look something like x cubed looks like that. So if it's been reflected, flipped, then it's going to look like that. So that means it's not this one, and that means it's not this one. Now, as far as this one's concerned, it's a, could it be this one, x to the power 7? No, because this is an even function. So it's not even close. You know, both sides go down like that. That's an even function. So the only candidate we have is that one. Now let's double check to make sure. Okay? All right. So you can always tell odd function from its end behavior. Okay, as x Normally, when x goes negative, then the function is coming downward, and and then it goes as x gets bigger, the graph goes positive. But this one's been reflected, so it does the opposite. Either way, it's still an odd function. Either way, because you don't have this business going on here. Let's go to Desmos. Let's go to Desmos and graph the function there. A negative x to the 7th. Yeah, I want to make sure x 7, that minus 2x 4. All right, so let's do that minus 2x 4. So that's minus. That's that. I just thought we were doing graph. And let's go y equals, it's okay to use y. It's the same as after that. Equals to negative x to the power of 7. Go down minus 2x to the 4. So, I want to pause it. Okay, what happened? Okay, I don't know what happened. Okay, all right. So anyway, as you can see from the graph, let's see, y'all. All right. So another way is you can also graph it. Okay? That's what we do here. But I usually try to use my own first. Okay, let's get back. So, and let's see if we can speed up a little bit. Okay, or you can always take a break. I could do this all day. And this video is already at, I don't even want to know what it is. But yeah, we're already at 22 minutes. So we got a whole lesson here. Okay, it's a long video. All right, let's keep going. I'll see if I can speed things up. All right, so let's see. All right, so let's move this over. The graph of this function here is transformed using given steps. Which graph represents transform? It's reflected across the x-axis, vertically compressed by a factor of 1/3, translated 2 units right. Told you again that x squared, if you look, if you look at the graph, you can do the whole thing with Desmos. And sometimes I just like to do it there. So I'm going to do this in Desmos. Even though it's best to do it, just do it. But let's go look at x to the power of 3. Okay, see what that graph looks like? You see what that graph looks like? All right, that's what x to the power of 3 looks like. Okay, so if we take that graph and we reflect it across the y-axis, what is that? That means it's going to flip across the y-axis. Keep in mind, it already looks like this. So now it's going to go like that. It's going to flip. And if we want to actually see that, I'm going to do it this way. All right, let's just go ahead and define the function. Now, x equals. Let's just do it this way. Let's just do it. Here it is. There's a function there. I'm going to make it a little smaller. Now, let's write this. We got reflected across the y-axis. All right, so I'm going to take this function. I'm going to create another function called g of x. I can call it that, and that makes it easier. All right, or yeah, let's do g of x. All right. And we're going to do this to f of x. So we're going to reflect it across the y-axis, not the x-axis. So that means I'm gonna go, I'm gonna take F, and I'm gonna go inside F to negative X. This is how you do a reflection across. Now you see you see it flip? That's what it did, it flipped. That's a reflection across the y-axis, about the y-axis. And then vertically compressed by a factor of 1/3. So that means I'm gonna come in front of the function and type 1 divided by 2. You see it got fatter? So it got fatter when we compressed it there. So, and then the next thing I'm gonna do is I'm gonna translate it 2 units to the right. So that means I'm gonna go to my X and I'm going to subtract 2 directly from the X. 2 units right, encoded. So that's my new graph. That's my new graph. I'm going to cut my old graph off. And so I'm looking for that bad boy. And which one is it? Is it D? Is it C? It looks like, well, since it's reflected, it looks like it's going to be A. Or is it? Let's look. We are 2 units past the origin on the left. Yeah, so A appears to be the correct answer. Nice if I actually that. Right, that matches like that. Okay. All right. So that's so let's keep moving. All right. All right. All right. This here one here we're not going to attempt to graph this. We are not. We're just going to use our rules here. So let's clear annotations. All right. Let's move all this out there. All right. So here's our graph. What can represent this? All right. Well, we're gonna know what our all right. What we're gonna do is okay. I've already done that. Hold on, let's get back to one. Yeah, here we go. Whoops, wait a minute. Let's go back. All right, this is what we're doing. We'll get to that one in just a minute. Okay, so let's go. Okay, so first thing you want to look at is right there. We got a reflection across the y-axis. Notice it's not on the x. It's going to flip over. Did I say y? X-axis. So it's going to flip over the x-axis. So I'm looking for this thing turned upside down. That's what I'm looking for. So that means I'm gonna get rid of this one, I'm gonna get rid of that one. All right, that's what I'm looking for. And then I'm looking for move 4 units, and I need this thing to be moved 4 units to the right. So 4 units that way. So look where it is. I'm expecting to flip and go on that way. So here is our answer here. Notice that this one goes that way. So the correct answer here is that. Let's keep going. All right, we're making enough time now. Graph for this last transform this function. This time it is reflected across the y-axis, vertically compressed by a factor of 1/2, translated 2 units left. Last time I did this with Desmos, here I'm just going to do it reflected across the y-axis. All right, let's remember the original function looked kind of like this. All right, so let's see. It looked kind of like that. So when we reflect it across the y-axis, then it's going to look like this. So I don't want this one, and I don't want that one. Okay. So then I want it compressed, so I want it fatter, and then I want it moved to the left. This one is moved to the right. This one is moved to the left. I'm looking at the origin, and it went that way. So yeah, away. All right. So A is the correct answer. Let's keep going. going. All right, we're making some progress. All right, all right, this should be pretty simple here. So let me go ahead and I do not like that green. All right, let's change this function. If we take this function, f of x to x and power 6, we change it to this function, how the graph transform? Identify the transformation. Okay, this is our a value up front. That is a vertical stretch. So we got a vertical stretch by 2. So which one of these are vertical stretches? A and C. All right, so we can get rid of B and D, we don't want it. So not this, not that. And then we're looking for to the left twice. This needs to go shifted 2 units to the left. So which one is shifted 2 units to the left? All right. This one is shifted 2 units to the left. So our answer is C, because this other one is talking about going 2 units to the right. So that's our answer. Okay. Let's keep moving. All right. And all right. Which of the following contains a complete list of possible rational roots for the polynomial? All right. We are looking for fractions that have the numerator. Oh boy, yeah. All right. We're looking for the numerator to be factors of 4. That's this one. Over factors of 5. Okay, that's what we want. So, all right, so we need the factors of 4 are 1, 2, and 4. So we're looking for something with 1, 2, and 4. And let's see, we don't see this, that, we don't see that. So just to make sure, because you have to have the factors of 4. And because the factors of 5 include 1, then these have to be in. Now, we also, if we include the factors of 5, then we also got to have 1 over 5 and 2 over 5 and 4 plus or minus all that. So that's why A is the answer. Okay. Let's keep moving. Well, what I hate is I can't clean this video up. I don't know quite how. I don't have the sophisticated software, so that's why it's taking us a while here. All right, and we're at 30 minutes. All right, but we're making progress. All right, well, let's just try to solve the polynomial equation below. Identify the step Y. Let's just make the first error. Okay, get to these red here. All right, so here's the first thing. First thing we need to do to solve this polynomial equation is we need to get rid of that 250. All right, so he's going to divide both sides by 250. Do that there, and we'll get that. Then that's going to leave him with 3 minus x to the power 4 fifths. That's going to leave. I know my 4s are ugly. Now the question is, how do you get rid of that 4? Well, what you don't do is you don't add, you don't raise it to the -4 power. You don't do that. What you do is you multiply it times 1/4. That's what you do. Well, you don't do it on that. Well, yeah, you actually do it. What you do on one side, you do on the other. So this is a mistake right here. The way you get rid of this 4 is that you multiply it times 1/4. You don't multiply it times -4. That's the first error. Right? Let's keep going. I'm gonna get tired of you saying this because. Oh, let's see. 5 more problems. 5 more. Again, I do recommend that you take a break, and then you can always stop and start this stuff. Oh, sorry, just have no brown out. There we go. All right. Okay, this one, yeah, I'll do this in the Desmos. Yeah, let's solve this in Desmos. Although you can solve it by hand, I'm going to do this short for you. All right, I'm going to let you read that. Okay. If we know the volume is, then that's what's going to go right here. We know what the volume is, and we're looking for the height. The height will be this x here. Yeah, is it? Yeah, all right. So let's see, what I'm gonna do is x equals 2. Good. All right, so let's go to Desmos with this. So they tell us what the volume is. The volume is that. And here's the equation. So basically, this is looking like this. So we're saying that V of x is equal to 1.55. We're just looking for the intersection of these two. So yeah, so we're going to graph this, and then we're going to graph that, and just see where they come together. All right. So I'm going to go to yeah, let's go to Desmos. And okay. All right, let's put in B of x. All right. So I'm going to do I need some room too. All right, let me get rid of this. X 22 minus 2 x 28 minus 2x. Then we also want to graph, I'm going to say y equals 1.55. Okay, let's do it all at once. Okay, let me move this up. Let me move this up. Okay, you can't see all this. Look what happens if I try to, when I try to do that, it's going to be hard to read. So what I'm going to do is I'm going to change my settings here. Oops, let me go back. And I'm going to make my y-axis big enough to account for this 1055. So I want this one to be, let's see if they'll let me, I'm going to make it like 1500. Ooh, man, it's too big now. You see it going crazy there. So 1, that's better. Okay. So all I want is an intersection. And so there it is. Real pretty, real easy to see. Okay. All right, we got two intersections though. If we put our cursor on one, there's one, there's the other. So if we look at our torus, this is close to 3, 2.99, that's 5.2. We back over here, we see that that's torus C. And that's how it is. That's how it is. Let's go to all right. And we're going to use a graph on this one too. All right. You read that. Okay. We're going to graph this function, and f of x is the distance in feet. So f of x is the distance in feet. So that means f of x is 100. Okay. We're trying to find the speed, which is x. All right. So how fast does this car need to go in all this? For how fast will the car going if it required 150 feet to stop? So, 9 x squared plus 2.1 x. There's no graph. Let's go ahead and put I believe, yeah. I use y, it does the same thing. Y equals to 0.49 x squared plus 2.1 x. All right, and then make sure I got that right. Oh no, 0.049. 0.049. So let me do another zero. There we go. All right. So that's the speed. That's the equation. So and we need 100 feet. So y equals to 100 feet. Now you do know that f of x and y are the same thing. So I can use those interchangeably. So there it is. Let's find out where they intersect. And I could just pull this up until I get to 100. And just, there you go, I guess we could do it that way. And just get that intersection. All right, so this car was going, since x is the speed, this car was going almost 29 miles per hour. So the correct answer here is B, okay? B is the correct answer to number 16. I think the key might say something. Correct answer is B. And this is the reason why. Okay? All right, let's keep going. Partner keeps a free ball at an angle. Let's see, read that one I write. All right, what time does the ball reach its maximum height? This graph is find the maximum. All right, I'm going to graph this function, change the t, this change the t to x. All right, what am I doing? And y, this is okay. And let's go 16. I believe it'll still work with t, but I'm going to go ahead and use x anyway. All right, that's going to be a negative 16. All right. And that's a plus 30x. And that's a plus 0.167. All right, there's our graph. Let's find the max. There it is. Yeah. So 0.49. So here we're going to write 0.40. Yeah, you know what? Go ahead and see that. Let's go right here. 0.49. No, backwards. So not that. Here, clear that. Clear that. is 0.94. Okay? And why is it that? Because of that graph right there. There it is. Okay? There it is, 0.94. You're only looking at the x value. That's what you're looking at. All right, so which of the following is not a possible rational root of the polynomial? Okay? Polynomial. Okay? Well, rational root it's got to be a factor of 9 over a factor of 2. So A is definitely true. What about 2? Yeah, it can't, just no way. 9 is a factor of 9. Negative 3 is a factor of 9. And of course, this is a factor of 9 and a 2, but 2 is not a factor of 9. So that's the answer. Actually, these should be X's. Okay? Yeah, because, 2 times, negative 2 times what is equal to 9? All right, so, not a factor. Let's keep going. All right, I like this problem. All right, which of the following here could be the equation of the graph? The long way would be to graph all 4 of these to see which one matches. It's much simpler to just look at the fact that this is an even function. It's like a W. Which of these are not even? Well, this is degree 1, 1, 1. This is an odd function. A is an odd function. So we're going to X it out. That's odd. And so is C. So, nope. All right. Now we got 2 even functions. And what really throws it around, you see that? That bounce? This is a double multiplicity 2. Multiplicity 2. So that means you got a multiplicity 2, and both of these have that at 0. So that doesn't buy us anything. All right. But this here, we have a 0 when X is 2. Because X minus 2 is 0 if X is 2. So we have a 0 at 2. So that's a 0 at 2. And we have a 0 at negative 3. Because negative 3 plus 3 is 0. There's a 0 there. So B is the correct answer. Here, the zeros are negative 2 and positive 3. That's not what the zeros are here. The zeros here are positive 2 and negative 2. And that's what we want. So, and finally, last problem. How long did it take us to get there? It took us almost an hour, but here we are. Problem is 28 minutes. So let's get there quickly. All right, and let's give it all this. Given a function f of x has a 0 at x minus x equals 3 with multiplicity 2, then we know that the graph of f of x crosses the y-axis at 3. We don't know that, and plus that doesn't have anything to do with that. A 0 is on the x-axis anyway. So no, A, nah, nope. No. All right. F of x approaches positive infinity as x approaches positive infinity. Actually, we don't know that. All right. By the way, what does this look like here? We got a function that has a that means it's going to bounce at negative 3 at 3, either that way or that way. All right. That's what it tells you. So we don't know. F of x approaches infinity as x goes to infinity. That's true there, but it's not true there. So we don't know this for sure. So we have the graph of f of x crosses the x-axis at 3. Well, that's a big no, because you can't have a multiplicity 2 if it's going through. So the only the only thing you got, it touches but does not cross the x-axis at 3. That's the only reason you're going to have a balance if it touches but doesn't cross. So, and that completes, you've come to all 25. So I hope this helped a little bit. Now go knock out that test. Knock it out. And I mean in a good way. Peace. Now how do I end this thing? Let's see. How do I end this? Oh, there's my face again. Yeah, I hope I record.